lecture we will discuss up to our step number 9, which is the forces on bottom chord. Okay, and after completing our step number 9, which is the forces on bottom chord, we will told that I am telling you that the design of bottom chord is as per n type of foot over bridge. Okay, and you all know that for through type of foot over bridge, your top chord member is always in compression and your bottom chord member is always in tension. But some students have doubts regarding how to design of tension member. Okay, so let us revise. And for revision of the forces of bottom chord, so first of all you can see that this is your first member L0 L1. Okay, so this is your first member L0 L1. Now at which point your force is maximum? So, as per discussed in our last lecture that your L0 L1's opposite end is U0. Okay. So, you can see that at U0 point your force is maximum. Okay. But after finding out the forces on bottom chord, you have to find out forces of diagonal member. Okay, so for forces of diagonal member, you have to find out forces on both the junction which is L0 and L1. Now, if you are finding out the maximum force which is at U0 point, so for U0 point, your left side distance is 1.5 meter. Okay, because the panel length is 3 meter, then half of the distance is 1.5 meter. Now, if your value of A is 1.5, then what is the value of L minus A? So, it is 16.5 because your value of L means total length of span, and in the question it is clearly mentioned that your total length of span is 18 meter. Now, 18 minus 1.6, so you will get your answer 16.5. Okay, so at this point, your influence line diagram's maximum value is 0.53. Now, at which equation this value will be get? So the equation is A into L minus A divided by L into H, in which your value of A is 1.5, your value of L minus A is 16.5 divided by L, which is 18 meter, into H. H means 2.6 meter. So this 2.6 meter is calculated in our step number 1. Okay. So students, after putting all this value, you will get your answer 0.53. But for bottom chord member and with the help of the diagonal members reference, you have to find out the value of L0 and L1 point. Okay. So you can see that for L0, L0 is your origin point. So for origin, the value is 0. Now for L1 point, so this is your L1 point. Now you can see that there is two triangle if you are considering at this point. So this is your left triangle and this is your right triangle. Okay. So for left hand side, you have to refer left triangle. For right hand side of value, you have to refer right triangle. Okay. So for the value of L1, you have to refer right triangle because you have to find out the value of right side member. So with the help of trigonometry. Okay, so you can see that this triangle, so at this point the distance is 0 and value is 0. With the increasing in the length, your value of influence line diagram is increased like this, linear increment. Okay, so you have to use, if the distance at this point from right hand side, you can see that it is 16.5. So for 16.5, your value is 0.53. Then you have to find out the value at this point. So this distance is 15 meter. Okay. So the equation is for 16.5, your value is 0.53. 0.53. Then what is the value for 15 meter? So the answer is 0.48. At the same, this is your second member which is L1 L2, and the opposite end of L1 L2 is U1. So at this point your value is maximum and the equation is remain same, A into L minus A divided by L into H, in which your value of A is 4.5, your value of L minus A is 13.5 divided by L into H, which is equal to 18 into 2.6. So you will get your answer 1.3. Now you have to find out for bottom chord value of L1 and L2. Now L1 is your left hand side portion, so you have to use this left hand side of triangle. So for this triangle, this is value for 4.5 meter. So the equation is for 4.5 meter, your value is 1.30. Then what is the value of 3 meter? So you will get your answer 0.866. And for L2 point, this is your right hand side of distance, right hand side of point. So you have to refer right hand side of triangle. So for linear increment, the equation is for 13.5, your value is 1.3. Then what is the value for 1 point? What is the value for 12 meter? So the answer is 1.15. Okay. And similar calculation for third member which is L2 L3. So students, you can see that your maximum area is for U2 U3. Now you have to find out forces, and you all know that for finding out forces your equation is area of influence line diagram into total UDL, which is calculated in step number 5. So your area of influence line diagram, so you have to find out area of this portion. Okay, so the area is, you can see that this is triangle. So this is first triangle and the equation is 1 half base into altitude. So you have to find out this portion's area. Second area is this point. So for this point you have to refer this triangle, and this triangle is 1 half base altitude. Okay, so for this point it is 1 half base altitude. Now remain portion is this portion, and you can see that this is your trapezoidal portion, and for trapezoidal portion your area is a plus b into h by 2. Okay, so with the summation of two triangle and one trapezoidal you will get your total area, and this total area is multiplied with total UDL and you will get your maximum answer is 418.6. It means you have to design for bottom chord for maximum value 418.61 kilonewton. Now it is already discussed that the design of bottom chord is as per tension member. So you all the students are moved to page number 32, in which there is section number 6. This section number 6 is referred as design for tension member. So you all the students are moved to page number 32, in which there is three design checks. First one is strength governed due to yielding of cross section. Second one is strength governed due to rupture, and at last it is strength governed due to block shear. Okay, so first of all you have to find out this is your maximum load. So this maximum load is considered as your design load. So your first step is to check how many areas, how much area is required to sustain this maximum load. Okay, so it means you have to provide it some area than the required area. So the equation is TDG is equal to AGFY by gamma m0, and this equation is given on page number 32. Okay, so you can see that this equation, in which first of all you have to find out AG. AG means area required. How much area required to sustain these loads? Okay, so TDG means design tensile load and the value is 418.61 into 10 raised to 3. Gamma M0 is 1.10 and the value of gamma M0 is given on page number 13 divided by Fy. Fy is yield stress and the value of yield stress is given on 250. Okay. So students, after putting all this value, we will get our answer 1841.88 mm square. It means you have to require minimum 1841.88 mm square to sustain 418.61 kilonewton. Okay. So you have to provide it more area than required area. Okay, because you all know that if you are providing more area, then it is sustained more loads. Okay, so your area required for single engine standard angle. Okay, because we have to use double IS angle for top chord member, so it is compulsory for joint point of view you have to use 2 IS angle for bottom chord also. So you have to provide it 2 IS angle. So for 2 IS angle you have to provide it minimum this area. So for single IS angle your required area is 920.94 mm square. Now with the help of steel table you have to check and you have to provide it your assumed data. Now your selected section is your not final section. Okay, so therefore we have to try some ISA. So you can see that our trial and error 2 ISA section is 125 cross 75 cross 8 mm on both the side of gusset plate. Okay, so this is your 2 IS angle. This is your single IS section and this is your double IS angle with GP. GP means gusset plate with longer leg horizontal. It means this is 125, this is 75 and 8 is our thickness. So your provided area is 3076 mm square. Okay. Now you have to revise check that if we are providing this IS section, then it is capable to take 418.61 kilonewton. So for that point of view, you have to use and you have to check three check. Okay. First is design strength due to yielding of cross section. This is given on page number 32. Second is design strength by rupture. This equation is given on page number 33 and this all the steps are covered in our last example, and the third is design strength due to block shear. Okay, these all the steps are covered in our last example, as well as this is the somehow revision of your elementary structural design in which there is steel components are there. Okay, so students, this is the end of your chapter number foot over bridge. Okay, now we are moving further to our next chapter. So your next chapter is design of gantry girder. So students, it is already discussed that in our introductory section that design of gantry girder is one of the part of design of industrial building. So for design of industrial building, this is the very most important chapter. Okay, and this chapter is very tough if you are not visualizing this all the structural components. Okay, so let us check what is all the components of your design of gantry girder. So basically you all know that this design of gantry girder, or it is also called as crane girder, is useful in industrial building in which we have to move heavy machineries or heavy loads and transfer it to one place to another place. Okay, so this is written like this. You can see that gantry girder or crane girder carry hand operated. Hand operated means in the past there is hand operated crane girders are that in which there is one member is sitting in the cabin and operating accordingly. Okay, But nowadays it is not useful, and nowadays it is EOT. EOT means electrically operated traveling crane. In industry buildings such as factory, this gantry girder is useful in factories, workshops and steelworks. And and the function of this this gantry girder is to lift heavy materials and equipment and carry them to one place to another place. But the main important word is within the building. Okay, outside the building premises it not using with the help of gantry girder or crane girder. Okay, so your crane girder and gantry girder is lift your material and transfer it to one place to another place. Okay, now it is already discussed that there are two types of food. There is two types of gantry girder in which first one is HOC. HOC means hand operated crane. So the capacity of hand operated crane which is useful in the past is only 50 kilonewton. Okay. Now in a recent days you have to use EOT. EOT means electrically operated traveling crane having the capacity of 10 to 3000 kilonewton. Okay. Now your first theory is components of crane girder. So you can see that this is your crane girder, this is your crane. This crane is having some hook over here. You can see that in this slide, this is your crane in which this is your hook over here. There is one hook which lift the loads. Okay, now this hook, you can see that this is hook, and this hook is operating on this is trolley which move longitudinally over a crane girder. Okay, now you can see that there is main members four in which first is crane girder. So this yellow color is your crane girder. Second one is trolley. So this is your trolley which moves horizontally on the crane girder. Third one is gantry girder. This is your chapter's name, and this is the one industry. Okay, so you can see that the beam on which this crane girder is raised is called a gantry girder. You can see that this is your crane girder, and this crane girder is raised on this section, this I section. So this I section is your chapter name, which is gantry girder, and your last member is rail. You can see that this is rail because your crane is moved like this, and this crane girder is moved on the wheel. This wheel is like the railway station's rail. Okay, so this is four main essential members of gantry girder. So this is your figure of one industry in which this is your steel column, this is your column bracket. This distance is called as minimum hook approach because your trolley is not moving left side from this point. So this distance is called as minimum hook approach, and similarly this is also your minimum hook approach. Okay. Now this is your trolley or crab. This is your crane girder, or it is also called as crane bridge. This is your crane girder. Okay, this is your column bracket. This component is this point at this point. Okay, this is this horizontal, this vertical portion is your gantry girder. So this is the example of your design of gantry girder. Okay, now you can see that the trolley or crab, as discussed earlier, that the trolley or crab, this is your trolley or crab on the crane girder can travel transversely along the crane girder. This is already discussed over here. Now you can see that this is your trolley, and this your trolley having four wheels, two wheels ahead and two wheels behind. So there is four wheels, one, two, three, four. Okay, and at last the crane girder have two wheel at each end, because two wheel at one wheel at is this side and another one end is this side. So two wheel at this point and two wheel at this point. Okay. So students, this is the basic introduction of design of gantry girder. In the next lecture, we will discuss about how the load transfer from crane girder to gantry girder. Okay. So students, this is the end of today's session. Thank you.